Okay, so here we've got exercise 6b, question 13, one of the worded application questions in the rates chapter. So we start off just by highlighting some key information. We're told that there's a tank that can be filled with water by two pipes running together in 11 on 9 minutes. So two things I'm going to do. The first is I will draw a really sort of basic picture of what's going on. So I've got a bigger pipe, call it that one, and a smaller pipe, and then both running into a tank. I will label it just because my drawings are pretty woeful. So first thing I'm going to do is I'm going to change that 11 on 9 and make it 100 on 9 just for ease of manipulation. And then I'm going to go ahead and draw a table which hopefully can sort of summarize what this question has in terms of information. So there are three properties I can look at with this question. So the obvious one is time. So I can look at time. I can also look at volume, so the volume of the tank, and I can look at rate. Now, the reason we look at rate, even though it's not explicitly mentioned in the question, well, the word isn't explicitly mentioned in the question, is because rates makes it really easy for us to do some stuff. So we'll talk about that shortly. So the first thing that we have is the two together, and we're told that takes 100 on 9 minutes. Now the volume of the tank we're not told, so we can just fix a constant to that, so let's call that V. And then the rate is just going to be volume on time in general. Okay, so in this case we're going to have V divided by 100 on 9. If you go ahead and flip the fraction and multiply across, what you'll end up with is 9V on 100. So that's the two together. Again, let me probably write that out just so it's clear. So together. Then we're going to have just the large one. And just for the large one, the time it takes, well, we don't know. So we'll call it T. The volume will be exactly the same as if they were together. So we'll stick with V. And then the rate is really simple, just volume on time. So we've got that there. Finally, we've got the small pipe. Let me just extend these further. Okay, so finally we've got the small pipe. The small pipe takes the same amount of time as the large one, plus 5 minutes. So that's that extra piece of information. So the larger pipe alone takes 5 minutes less to fill the tank than the smaller pipe. Right, so that means that here we're going to have T plus 5. Our volume is still going to be V, and our rate is now going to be V on T plus 5. If you wanted to go ahead and label that as, if you want to label the small as the T and then the large as the T minus 5, that works as well. It's equally good. Alright, so let's go ahead and try to set up a couple of equations and see what we can do with it. So one thing that we know is that if I had water coming through this one and through this one, if I add the two rates up, I should get this rate that I get together. Okay, so this is why we like to use rates. So just coming back to my point, right? So with rates, we can actually add them up, which makes it easy to set up an equation. So when we look at the time, for instance, if I wrote down 100 on 9 equals T plus 5, that is absolutely wrong, right? In fact, we should expect that this will be smaller both than this one and than this one, right? So each of them alone should be a higher number than the two together because they should flow faster if they're together. So this is no good. But with rates, we can absolutely just write down the two rates and they should combine to give us the same rate that we want. So we're going to take this thing here, so 9V on 100, and we're going to make it equal to these two things here. So we end up with 9V on 100 equals V on T plus V on T plus 5. From here, it's a fairly, hopefully, a fairly straightforward manipulation. So the first thing I'm going to do is just cross multiply. So I end up with, just to make it clear again, I'm going to multiply both sides by T and by T plus 5. So basically timesing that side by t on t plus 5, timesing this thing by t, t plus 5, and same thing with this one. The whole idea being to get rid of these denominators. Okay, so I end up with 9v t plus 5 on 100 equals v t plus 5 plus v times t. Okay. These are not my finest t's ever. Let me try that again. Okay. So now it's kind of starting to look better. So I'm going to go ahead now and multiply both sides by 100. Just again to make life easy. Note, this is not necessarily a mandatory step. So if you wanted to do these two steps together, that's perfectly fine. So I end up with 9v t plus 5 equals 100v t plus 5 plus 100 vt. It's a v there. Okay, so now we go ahead and expand the brackets. So we end up with 9vt squared. No, actually, before we do that, in this case, we have a v here, a v here, and a v here. So if you've been paying attention in methods or whichever subject you first saw factorizing in, hopefully that you've seen the idea that we don't actually usually want to cancel. So we usually would not want to just go, let's just cancel these v's, because what we're implicitly doing is dividing by v. And that doesn't work if v equals 0, and sometimes that means we lose a solution. So that can kind of be problematic. But in this case, we don't actually care, because if v equals 0, this question is trivial, meaning that if v equals 0, then the tank has a volume of 0, so it's kind of a nonsense question. So the only cases we care about is where v is positive and non-zero, so we can go ahead and cancel it out quite confidently, and so then we can expand. So we get 9t squared plus 45t equals 100t plus 500 plus 100t. Again, just rearrange all of this by taking everything to the left. Okay, so now we go ahead and rearrange it by taking everything to the left. So we end up with 9t squared minus 155t minus 500 equals 0. Which initially, I admit, looks quite gross, but if you play around with it, you will find that you get 9t, I think it's plus 25, t minus 20. That should work, because 9t minus 20 is negative 180. At 25 on, we get negative 155 equals 0. And so we get two solutions. Our first solution is 25 on 9, actually negative 25 on 9, and our second solution is 20. Okay, so in this case, it's quite easy to say, well, clearly t cannot be negative 25 on 9, so this is not feasible. Therefore, time to fill larger tank is 20 minutes, and smaller tank is 25 minutes.